Hello everyone and welcome back to vians.org. We are today going to work on the second chapter of your CBSE math class. Basically CBSE 10th math textbook, whatever you have over there. We're working with the second chapter of it, that's on polynomials. So we've divided this into two sections. The first section that we're going to right now work with is just working with what's a polynomial, how do you define a degree of the polynomial, how do you find the roots of a polynomial or zeros of a polynomial, and how do you find the zeros as well as coefficients, what's the relationship between the zeros and the coefficients of a polynomial that's quadratic or cubic in nature. So that's what is going to be covered in this section. And the first section is going to give you a background about what this first part comprises of. It's going to give you some proofs, some theorems, and some basic problems, and then we'll have another session that works with all the CBSE problems as well as some additional problems that we will work out for you to get a better understanding of this. All right, so without much ado, let's get into the first the beginning of this particular chapter. Now, polynomials. What are polynomial? Polynomial is any relationship between multiple variables that can be expressed in a certain form. Okay, for example, there's a relationship between constant and a variable over here x, and that can be explained as 3x plus 5. All right, so 9x squared plus 3, 36 is another polynomial. So when you say that there is a polynomial, it's normally defined in the form p of x, where x is what's going into your polynomial. It's the variable in your polynomial, and the highest power of x is called the degree of the polynomial. For example, the highest power of x in this particular case is 1, so the degree is 1, and this is called a linear polynomial. If the highest power of a particular in this particular equation, if you see, the highest power of x is 2, so this is again p of x, and the degree of this polynomial is 2, and that's called a quadratic polynomial. In this particular case, the highest power of x is 3, so that's actually a polynomial of degree 3. That can be written as p of x as well, a polynomial of degree 3, and it is a cubic polynomial. 4y raised to power 4. Okay, so in this particular case, this would be a polynomial of not x but y, because y is the variable that's gone into it. And if you see, the highest power over here is 4, so this has a degree of 4, which is basically a biquadratic polynomial. This, if you see, is again a polynomial in the variable x, and the highest power you see is 1, 2, 4, 5, 6. So this is a degree 6 polynomial. So that is what is called the degree of a polynomial, and dependent on the degree of the polynomial, you will have that many roots of the polynomial or zeros of the polynomial. Before we go into that, what's a value of a polynomial? Now, a value of a polynomial p of x can be defined as that value of x which is put into the which you need to substitute into the polynomial. For example, p of x is equal to x squared minus 3x minus 4. If I say that I want to substitute 2 into it, then it would be 2 square minus 3 into 2 minus 4. So that would be 4 minus 6 minus 4, cancel this 4, and it would be just minus 6. So that would be p of 2. Similarly, you could find p of 0, which is nothing but the value. So basically what you're trying to do is, if you had a line, okay, a linear line, then p of x would be nothing but your value of this particular equation, that is x squared minus 3x minus 4, at this point 0, or say at the point 1, what would be the value of this line? In this particular case, if it's a biquadratic, if it's a linear equation, it would be a line. If it's a biquadratic equation, it would be, depending on the equation, how would you plot it? So that would be the shape of it, and what would be the value on the y-axis, depending on the x-axis value or x-axis value. That is what you're trying to find out over here. So for example, if I wanted to find p of 0, what I'm trying to find is the value of this particular polynomial x square minus 3x minus 4, which could be nothing but y. So value of y at when x is equal to 0. For example, p of 0 is equal to x square minus 3x minus 4. You can substitute 0 instead of x, so that would be 0 square minus 3 into 0 minus 4, so that would be just minus 4. Alright, so that is called the value of a polynomial. Now coming to the zeros of a polynomial. The zeros of the polynomial are the values of x at which p of x is called x is 0. Basically those are the roots of the polynomial or zeros of the polynomial, in which case x is a real number. Alright, so it can't be an imaginary number. Example, p of k is equal to k square minus 3k minus 4. Now how would you normally find out what would be the value? So you would have to simplify this particular equation. It's a quadratic equation. At what value, if you had to find zeros, what value would the p of k be? 0. So k square minus 3k minus 4 is equal to 0. Now you need to first of all rewrite this equation in such a manner that you can find common factors on both ends. How would you do that? So first of all, factorize the product of your first number as well as your second number. So that would be k square, so that is 1 into this is 4, minus 4, right? So that's minus 4. Now let's try to factorize 4. 4 can be factorized, or 4 can be written. Let's not factorize. Alright, so how would you do that? So k square minus 3k minus 4. So in order to solve this particular equation, first of all, you would need to factorize 4. How would you factorize 4? 4. 2 2s are 4, 2 1s are 2, right? That's one factor. So now this can be written in multiple ways. This can be written as 2 2 or 4 1 or 1 4, right? These are the three ways in which you could write that. Now you need to write it in such a way that the sum of the numbers over here would be minus 3, and the product of this numbers would be this and this, multiplication of the constant of the first k square as well as 4. So what would that be? That would be, for example, if I wrote this as minus 4k, minus 4 into 1 would give me minus 4, minus 4 plus 1 would give me minus 3. So I could write this as k square minus 4k plus 1k minus 4 is equal to 0. I can remove k, so that would be k minus 4 plus 1, k minus 4 is equal to 0. This would be nothing but k plus 1 into k minus 4 is equal to 0, which is nothing but k is equal to minus 1 and 4, right? So that is what is the zero of this particular equation, zeros of this particular equation. Now let's take another problem. Find 0 of the polynomial 2x square plus 5x minus 12. So it's going to be 2x square plus 5x minus 12. So what do you see? 12 2s are 24. So you need to find first of all factors of 24 such that when 24 is when those factors are multiplied, you get minus 24. So let me consider that those factors are alpha and, or let me consider those alpha products are a and b. Then when they multiply, you should get minus 24, and when you add them, you should get 5. Okay, find such products. So 2 12s are 24, 2 6s are 12, 2 3s are 6, 2 3 1s are 3. Right, so the products, so the factors of 24 could be 2 2s are 4, 2s are, so it has to be only two numbers. So it could be 8 and 3, or it could be 3 and 8, or it could be 4 and 6, or it could be 6 and 4, or it could be 12 and 2, or it could be 2 and 12. So however you write it, these are the factors that you will get, or it could be 24 and 1, right? So these are the factors that you're going to get. Now if you see 12 minus 2 or 12 plus 2, or however you write it, this is not going to give you 5. Okay, 24 minus 1, this is also not going to give you 5. 6 plus 4, that's going to be the 10, or 6 minus 4 is going to be 2, so that's not going to give you 5. 8 plus 3 is 11, but 8 minus 3 is 5. So you could always write this as 2x square. You need a minus, so you need to know that 8 and 3 would have either both be negative or one of them negative and one of them positive. That's how, if both of them were negative, then this would be positive. So one of them has to be negative and one of them has to be positive, and the 8 needs to be, the bigger number needs to be positive. Only then you can, when subtracting, get a positive 5 remaining. So it has to be plus 8x minus 3x minus 12 is equal to 0. This can be written as x plus 4 minus 3x plus 4 is equal to 0. When you factorize this, this can be written as 2x minus 3x plus 4 is equal to 0. In short, x is equal to 3 by 2 or minus 4. That is what, if you've noticed, these are the zeros of the polynomial, and that's what I've got over here also. So x is equal to 3 by 2 or minus 4, just in case you're not able to understand my handwriting. So this is how you define zeros of a polynomial. You need to always make sure that the product of these two numbers, right, that there should be two numbers that when multiplied give you the product of these two numbers for a quadratic equation, product of these two numbers, and when added gives you this particular number, right? So that's about the zeros of a polynomial. Now we'll go into relationship between the zeros and coefficients of quadratic polynomials. Now you will understand why I factorized it the way I did. So before we look into this, let us take a particular equation into consideration. Let us take an equation which can be written as f of x is equal to ax square plus bx plus c, where a is not equal to 0, because if a becomes 0, this would have become a linear equation with just x as the highest part, so a can't be 0. Alright, now let us consider that there are two roots, so two zeros of this equation, basically alpha and beta, such that x minus alpha and x minus beta are factors of f of x. Alright, so in that case, ax square plus bx plus c can be written as k into x minus alpha into x minus beta, right? Where k is just some constant. Now how do you multiply this? You're going to just multiply this. X into x square minus alpha x minus beta x plus alpha beta is equal to k into x square minus alpha plus beta x plus alpha beta is equal to ax square plus bx plus c. So once that's done, we could say that your k, you can compare the coefficients now. Kx squared is equal to x squared, so k is equal to a. B is equal to nothing but minus k into alpha plus beta, alright? And c is nothing but k into alpha beta, right? So k is equal to a. Once you know that, once you substitute this k is equal to a here, you would get alpha plus beta is equal to b by minus k, that's b by a, minus b by a, or alpha beta is equal to c by k, that's c by a. So that is what you would get. So if you see, that gives you the relationship between the zeros of this polynomial and the coefficients of the polynomial. So alpha beta is equal to c by a and alpha plus beta is equal to minus b by a. If you go ahead and see, that is exactly what I've explained over here as well. So that's what you get to see here. That's the equation that we've done the same thing over here. We've written that x and b, alpha and beta are the factors and or the zeros, and so this is the form in which you could express. You would still get the same equations, and when you subtract, you would get the same form, right? So basically a polynomial, quadratic polynomial, can be always written as x square minus alpha plus beta x plus alpha beta. And that's why I said that the product of a and c has to be the product of alpha beta. And that's how basically you would solve, or you would find the roots or zeros of that equation. Now, relationship between zeros and coefficients of a cubic polynomial. Now this is a pretty similar concept that we're going to work with. So the concept for this is that you could consider an equation of the form px is equal to ax cube plus bx square plus cx plus d, where again a is not equal to 0, right? Now consider that alpha, beta and gamma are zeros of this equation, such that x minus alpha, x minus beta and x minus gamma are zeros, or are factors of this p of x. Then what would happen? Then you could write ax cube plus bx square plus cx plus d is equal to k into x minus alpha, x minus beta, x minus gamma. Alright, so again this could be expanded. This k into x minus alpha could be expanded as, multiplied now, x square minus, this is going to be beta x, this is going to be alpha x, this is going to be alpha beta, and this has to be multiplied by x minus gamma, which can be again written as x cube minus beta gamma x minus alpha gamma x plus alpha beta gamma, or actually alpha beta, sorry, this can be written as k into x cube minus, multiply x by this thing, so beta square x square minus alpha x square plus alpha beta x minus gamma x square plus beta gamma x plus alpha gamma x plus alpha beta gamma. This can be written as k into x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus alpha gamma x plus alpha beta gamma. Alright, so that is how you could write that particular equation. So now you could compare the coefficients. That's your k would be nothing but, if you see over here, your a would be nothing but your k. Your alpha plus beta plus gamma is minus of alpha plus beta plus gamma is going to be into k is going to be equal to b. So we could write k is equal to a minus alpha plus beta plus gamma is equal to b by k, which is nothing but alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus alpha gamma that you got from here is equal to c by k. C by k, because k is there in the beginning, so c by k, that's c by a, and alpha beta gamma is equal to nothing but d. So d, alpha beta gamma into k is equal to d, so this is going to be d by a, because a is equal to k. So that's exactly what I have shown in this particular section. So we've done the exact same thing. We have expanded using x minus alpha, x minus beta, x minus gamma, and we've got this particular equation, And then we have found that alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus alpha gamma is equal to c by a, and alpha beta gamma is equal to minus d by a. Now a cubic polynomial can then be written as x cubed minus alpha plus beta plus gamma x square plus alpha beta beta gamma plus alpha gamma x minus alpha beta gamma. All right, so this is the equation. Now let's solve a few problems before we go into the actual CBSE problems, but let's solve a few problems to get the hang of what we covered in this chapter. So find the zeros of the polynomial 2x square plus 5x minus 12. So 2x square plus 5x minus 12 is equal to 0. What do you need to do? First of all, you need to find 12 factors of 12. 2 6 are 12, 3s are 6, 3 1s are 3. All right, and then there's another 2, right? So the factors are going to be 2, 2, 3, 2. How are you going to write 24 using that? Minus 24 using that, such that the sum would be 5, but the product would be this. So we've already solved this, if you remember, just a while back. So that's going to be written as either 8 3, 3 8, 6 4, 4 6, 12 2, 2 12, or 24 1, 1 24. But again, you know that the sum has to be, or the difference has to be 5, so it's going to be 8 and 3, so that can be written as 2x squared plus 8x minus 3x minus 12 is equal to 0. That can be written as 2x into x plus 4 plus 4 minus 3 into x plus 4 is equal to 0. That's x is equal to minus 3 by 2 and minus 4. Sorry, x is equal to plus 3 by 2 and minus 4, right? Let me subtract this for you. Yeah, 3 by 2 and minus 4. So these are the zeros of this particular equation. Now let's find the coefficient. So to find the relationship between the zeros, to verify that relationship, we know that alpha plus beta is equal to minus b by a, right? So the LHS alpha plus beta can be taken as 3 by 2 minus 4. So that's 4 2s are 8, so 3 minus 8 by 2, that's minus 5 by 2. Now the RHS is nothing but minus b by a, which is nothing but minus 5 by 2. So LHS is equal to RHS, hence verified. Similarly, if you wanted to find alpha beta is equal to c by a, you would do alpha beta is equal to 3 by 2 into minus 4. That would be minus 6, right? And c by a would be equal to minus 12 by 2. That's minus 6. So LHS is equal to RHS, hence verified. If you go ahead and see, that's what we've exactly done over here. We have found the root to be 3 by 2 and minus 4, and we've done the exact same thing over here as well. Now this is the first question that we're working with. There's another question. So find the zeros of the polynomial x square minus 2. We know that this is of the form x minus root 2 into x plus root 2. So x, and if that's equal to 0, then x has to be root 2 or minus root 2, right? So those are the factors. And if I had to find the relationship between the zeros, then alpha plus beta is equal to minus b by a, wherein LHS is equal to alpha plus beta is equal to root 2 minus root 2 is equal to 0, and b by a, let's see, minus b by a is equal to 0 by 1, so that's 0, so hence verified. And if I had to prove alpha beta is equal to c by a, I would get alpha beta, so I would get basically LHS is equal to root 2 into minus root 2, so that would be minus 2, and RHS would be equal to c by a, that's minus 2 by 1, so that's again minus 2, hence proved that that is true. You see, that's exactly what we've done over here as well. So you're getting the same minus 2 and 0, and you're getting the same roots. So that's the particular solution to this equation. There's another question here that says find the quadratic polynomial. The sum of whose zeros is alpha root 2. So let's consider there are two zeros, that's alpha beta, such that alpha plus beta is equal to root 2 and product is equal to minus 12. Now, what are the factors of 12? 12, 2 6 are 12, 2 3s are 6, 3 1s are 3. Right? Right. So 12 factors are 2, 2, 3. We need something that gives root 2, right? So we could write this. So the sum has to be root 2. Now, how could we write this such that the sum is root 2? We know that is 3 into 4, right? So 12 is nothing but 3 into 4. Or this could be also written as 3 root 2. I could split the root 2 amongst both of them. So that could be into 2 root 2. That's 24. And that can be also written as, so alpha plus beta could be written as 3 root 2 minus 2 root 2. So hence, I could write this equation as x square plus 3 root 2 minus 2 root 2 x plus 3 root 2 into minus 2 root 2 is equal to 0. I could take x as common from these two. So that would be x plus 3 root 2 minus, I could take 2 root 2 as common from both of them. And that would leave me x plus 3 root 2 is equal to 0. So that would give me x is equal to minus 3 root 2 and 2 root 2. These are the zeros of the polynomial. If you go ahead and see, that's exactly what we found, 3 root 2 and minus 2 root 2. Alright, just in case you have a problem understanding my handwriting, please pause here and take a chance to look at this problem. And if you have any questions, please get back to us and we'll help you solve that. Now, consider a cubic equation, 3x cubed minus 5x squared minus 11x minus 3, and verify the relationship between the zeros and coefficients. So, first of all, it says that verify the zeros of the cubic polynomial are 3, minus 1, and minus 3. So, let's write p of x is equal to 3x cubed minus 5x squared minus 11x minus 3, which is nothing but p of 3. If I had to find whether 3 is a 0, I would substitute it there. So that would give me 3 cubed minus 5 into 3 square minus 11 into 3 minus 3 is equal to 3 into right? We're going ahead. That would be 11 minus 3 minus 5 plus 11 minus 3. So that would be 0 again. And let's substitute again. Minus 1 by 3. So that's going to be 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3. What would that be? I can subtract 1, 3 and here over here. So that would be minus 1 by 9. That would be 5 by 9. That would be plus 11 by 3. So that would be minus 3, which can be also written as minus 1 plus 5 plus 11 3s are 33 minus 9. So this is 1. So you've got to multiply the numerator and denominator by 9. So that's going to be 9 3s are 27 by 9, right? So 27, 27, did I miss something? Yeah, I missed one thing over here. This should have been minus 5. right? This should have been also minus 5 because it's minus 5 into minus 1 by 3. So that would have made it positive. So 27, 28 plus 5 is going to be 33. 33 minus 33, if you subtract everything, that's going to be 0 by 9. That's just 0. Hence, I have verified that, and that is exactly what I've shown over here. That's exactly what I've done. Substituted 3, substituted minus 1, and then substituted minus 1 by 3 to get you exactly 0, and therefore proved that these are the zeros of the polynomial. If you had to verify the relationship between the zeros, how would you do that? So first of all, you would use the formula that you already know. Alpha plus beta plus gamma is equal to minus b by a. Right? So that's going to be 3 plus minus 1 by 3 minus 1. So that's take all the denominator to 3. 3 3s are 9 minus 1 minus 3 divided by 3. So that's going to be 9 minus 4. Sum of these two. That would be 5 by 3. So that's what would be your minus b by a. So your b is minus 5 and your a is 3. Right? Similarly, alpha beta plus beta gamma plus alpha gamma is equal to 3 into minus 1 by 3 plus minus 1 by 3 into minus 1 plus 3 into minus 1. So that's going to be, if you solve that, that would be alpha beta plus beta gamma plus alpha gamma is equal to, if you solve that, that would be minus 1 plus 1 by 3. So because this is going to subtract and this is going to give you minus 1, this is going to give you plus 1 by 3, and this is going to give you minus 3. So that's going to be, if you take it to the common denominator, that's going to be minus 3 plus 1 minus 9 by 3. So that's going to be minus 11 by 3. That's C is going to be your 11. Sorry, C is going to be minus 11 and A is going to be 3. And alpha beta gamma is equal to 3 into minus 1 by 3 into minus 1. That's 3 cancels, and minus 1 into minus 1 is just 1. So that's going to be 3 by 3 is equal to minus D by A, which is nothing but minus 1, right? So minus of minus 3 by 3, so that's going to be 3 by 3, that's 1. So D by A is also equal to this value. So we've just proved the relationship between zeros and its coefficients. Alright, so that's what we've shown over here, and that's how we come to the end of this particular chapter. That's about it. If you have any other questions, or if you have any further doubts, please feel free to comment in the section below, or come to beanswer.org, where we will be going through CBSE problems that have been asked in question papers, previous year's question papers, from the section that we just covered on polynomials. That's basically the zeros as well as the roots, zeros as well as the coefficients of a quadratic or a cubic polynomial. So anything that has been taken in this particular section, we'll do it pretty soon. And please visit beanswer.org and study well. Thank you and have a good day.